Okay. So if anyone wants to watch this later. So let's do the first example. Let's say I ask you to graph y equals, and what was it again? 2 times 3 to the x plus 1. Okay. So the process I would do is I would start with y equals 3 to the x and make a table 0, 1, and -1. And then I'd make a second table for the equation that we're interested in graphing, but by making adjustments to the first table. So obviously, if you plug in 1, you should get plug in 0, you should get 1. Plug in 1, you should get 3. Plug in that way, you get 1/3. Now, in my equation here, remember the general form is this. So what's A here? What's A in the original equation?
2.
2. What's
2.
H?
1.
-1.
-1.
-1.
And is there a K value?
No.
Nope. Okay. So remember, A impacts Y, so you multiply these by 2. And H impacts X, so you're going to subtract these by 1. So you should get -1, 0, and -2. You get 2, 6, and 2/3.
Mr.
Yeah, go ahead.
A lot of the times I find it easier just to plug in 4 different numbers.
Sure.
Just get the answers. Will you make us write down like a parent function on the test?
No, I'm just giving you
Okay.
a process, but I mean, if you know, like, okay, like, to plug in like negative, one thing you could do is that you could realize, well, let me plug in a value for x that makes the exponent 0, which of course is -1, and then we go one higher, one lower. That works too.
Okay.
Yeah. So anyway, once we do that, and I'll get to the questions just a little bit. Let me just finish this problem up. So yeah, just plot it, right? So that's not hard. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2. And then of course, -1, 2 is right here. 0, 6 is way up here. Oh, I meant to put -1, 2 right there. My bad. And of course, -2, 2/3 are right here. There is no vertical shift, so the asymptote will still be at 0. It did shift 1 left and did get stretched. So you have to graph that. So I will ask for 3 points. I will ask for the asymptote. For the domain, it is all real numbers. That's going to be true for all these problems, just so you know. Yeah, and I will ask that every single time for each of the 3 graphing questions. So it's a free point. The range will be dependent on how the graph is opening. If it's above the x-axis, below the x, or just if it's flipped or not flipped. And of course, the horizontal asymptote, which is at y equals 0, so it's going to be 0 to infinity. The asymptote, you have to give the equation, which is y equals 0. And then finally, I'll ask you to state the transformations from the parent function. And I will even say what the parent function is. It's y equals 3 to the x. So I'll ask you to do that. And I'll have like a field where you fill it out. So you shouldn't forget to do it because the field will be there. It'll just be like a little table that you have to just put this stuff in or fill the blanks. And the transformations will be clearly we vertically stretched by a factor of 2. And just I'm only going to do 2 transformations per graph. I don't want to do anything too complicated, so I'm going to keep it pretty basic. So vertical stretch by a factor of 2. And of course, shift 1 right, 1 left. Okay, so now we have some questions. So Isabel, go ahead. What's your question?
Well, it's not about this. It's about a different.
About what word problems?
Yeah.
Okay. So I'm doing the graphing right now. I'll get to word problems in a few minutes. I just want to just kind of just show like people just some sample problems. And was there another question, Lizzie? Did you have a question? Like I said,
Yeah, I think my question was, are you gonna give us the parent functions on the test?
yeah, I'll tell you what the parent function is. What you have to compare it to.
Okay, and then does it really matter like what points we plug in for X?
No, it's up to you.
Okay, so
I wouldn't do like say like 4.
no, yeah, I just mean like
or like a fraction, but
I just mean like you did 0, 1, and like negative
sure.
2. Could you do like negative 1, 1, and 2 or something
You
like that?
can. I just chose these because these are kind of in the middle. Like 0, 1, and -1 are kind of in the middle of the graph. So that's usually a good 3. That I did for the parent function. Then I made an adjustment, knowing that there's a shift of 1 left because of the +1, the exponent. So then I took away 1 from each x coordinate from the parent function. Yeah, I do give you the parent function. I do tell you what the compare.
Oh, you took away 1 from each X
X coordinate. Yeah, of course.
coordinate.
Yep.
Okay.
Yep.
Wait, Mr. E, did you just say you give us a parent function on the test?
I'll tell you
Okay.
what the parent function is for this equation. Sure. I'll tell you. I'll tell you the parent. I'll tell you the parent function for this equation is y equals 3 to the x, and I need you to create the
Okay.
transformations.
And we have to make the table.
I won't tell you the table. I'll show you the graph, but I'll tell you what is the parent function. It is y equals, in this case, y equals 3 to the x.
Okay, sorry, that makes sense.
No worries. Yep. Okay, so what I'm going to do now is clear this out. And then we'll get to the word problems in a little bit. Clear this out. Shoot. Just getting kind of lazy. I don't want to redo all this. Okay. So next up, we have what? Negative on the outside, 1/2 raised to the x and -2. Excuse me. So of course a is -1, h is 0 this time, and k is -2 because you're comparing it to this.
Are
The
we gonna
parent-
have to state A, H, and K, or
No.
is it just, okay?
No, but I mean, I'm just doing it just because of the technique I'm using. It'd help for sure. The parent function is this: y equals 1/2 to the x, and usually, I do 1, 0, 1, -1 to the parent function. Plug in 0, you get 1, 1/2, and 2. And how am I using h and k? Is that I then use those values to make adjustments to the parent function. So clearly, it's not shifting horizontally because h is 0 because there's nothing being added, subtracted directly to x. So I can keep the same x coordinates. And then you could plug those back in to the the equation that we want to graph, or you can make adjustments. You're going to multiply by -1 and subtract 2. Multiply by -1 and subtract 2. Multiply by -1 and subtract 2. I'll put this in parentheses just to show I'm doing a subtraction. Gosh, I just really made that ugly, didn't I? There we go. So of course that's -3 and -2.5 and -4. And again, you can always plug it back in to see for yourself. That's what we get. And just graph it, right? Not hard. 1, 2, 3, 4. 1, 2, 1, 2. 0, -3. -1, 4. And 1, -2.5. Now this one's a little strange because it's going to look like this. It is decay because the base is 1/2, but it kind of looks like growth. The reason why it looks like this is because we had to flip over the x-axis because of the negative out in front. And shoot. Let me space this a little better. I did a kind of terrible job of spacing this. Is give me 1 sec, AJ. So let's space this a little more nicely. So much better. Okay. So 0, -3, 1, -2.5, and -1, -4. There we go. Yeah, and there is a horizontal asymptote at -2 because it did shift 2 left. Sorry, 2 down. Domains all real numbers. Range, now it's going from -infinity up to -2, non-inclusive for -2. The asymptote is y equals -2. And in transformations, it did reflect about the x-axis. We know that. And it shifted 2 down. Okay, AJ, go ahead. What's your question?
I was gonna ask that, like, usually isn't it decay if it's like a fraction?
Yep, well, between 0 and 1. Because
Between 0
for example, 3/2 is a fraction, but 3/2 is bigger than 1.
Oh, okay.
So between, yeah, I mean, I know what you mean, but just to be more precise in our the wording we use, it's between 0 and 1.
Okay, rad, cool. Thank you.
But because of the negative, it does look like I mean, it is y is increasing obviously as x gets bigger, but that's because of the reflection that we did. But at the parent function, of course, y equals 1/2 to the x is totally decay, right? Okay, Haley, go ahead.
So that's growth.
This is decay still because because the base is between 0 and 1.
Okay.
Even though it looks like a growth, but it's not because it got flipped. It got
Oh,
flipped because of negative out in front.
so you shouldn't like really base it on what it looks like, I guess. Like
No,
it should be.
no. It's purely based on the base.
Will you
No
ask?
pun intended, but
Will you ask, is this growth or decay?
I'm not that for the 4th time. I'm not asking that.
Oh,
Yeah,
okay.
don't worry about it. Okay, it's all right. No. Okay. And then let's do one more with E, and then we'll get to the word problems. Okay, let's erase this. Erase all this. Erase this. Okay, with E, it wasn't one I had here. It was okay. E to the x minus 1 plus 3. Okay. So you're gonna start with E to the x. Then remember, E is 2.7. I'll let you guys use a scientific calculator if you need to for this part, but E is just 2.7. And again, I'm going to use a 0, 1, and -1. A value is 1, so there's no vertical stretch or reflection. H is 1, K is 3. If I plug in 0 into E to the x, of course, I get 1. Plug in 1, I get E. Plug in -1, I get 1 over E. E is roughly 2.7. 1 over E is about 0.3. It's almost like 1/3. Actually, no, it's probably less than that. I don't know. It's somewhere between 0 and 1. You know that. It's 1 over 2.7. It's a fraction, so it doesn't have to be totally accurate. Then we make adjustments. Of course, we shift 1 right, so it's 1, 2, and 0. Again, if you plug 1 into x, it makes the exponent 0, and then plug in 1 higher, 1 lower, if you want to do it that way. Of course, you're adding 3 each of these. So it's 4, E plus 3, and 1 over E plus 3. E plus 3, I know, is about 5.7. And this is going to be like 3 point something. I don't know what exactly, but we'll graph. 1, 2, 1, 2. Make this higher. 1, 2, 3, 4, 5, 6. 1, 4 is right here. 2, 5.7, about there roughly. And then at 1, 4. and then 0, comma, like 3 point something. And I know the horizontal asymptote is dependent upon that value, so I know it's going to get close to 3. So I kind of feel good about putting a dot at 3 point something. Graph looks like that. Domain's still all real. Range is from 3 to infinity. There's an asymptote y equals 3. And clearly we shifted 1 right. And we shifted 3 up. So it's definitely there's some repetition, but it's a good thing because it helps reinforce the skill. But yeah, that's really how the test is going to go. The first 3 questions. I'll do a variation of this equation. Like maybe I'll have a different h value, different k value, or an a value, like something like that. But likewise the other 2 I did. Questions before we talk about word problems? No? Okay. All right, so this is perfect because we're about halfway through. Now, word problems. No, Isabel, I know you had a question. Thank you for being so patient. Do you have a specific question about a word problem that you want to ask?
I was just gonna ask you to go over
Hmm?
like what all the letters mean.
Oh, sure. Yeah, no problem. Yep. Okay. So let's talk about and welcome whoever joined us. Looks like Wiley. There we go. Great. Welcome, Wiley. Yeah. So let me put the formulas down because these will be applicable to the next 2 word problems we'll do. So P times 1 plus R over N raised to the MT power. And then here's another one. So hopefully this seems intuitive. T is time. So there you go. R is the rate, right? First letter. T is the principal, and I'll use that term principal. Principal just means what you start with, your initial investment. And N is the number of times you compound. So it's all should be very intuitive. Let me type up what I could ask. It shouldn't be too hard to figure out what's what, because honestly, these letters are basically the first letters of all of the terms they represent, right? Interest rate, R, time, T, number of times we compound, N, principal, P. That's all. That's it's just there's some reason to it. So let's see here. Let's see.
Can we do number 2 from the review guide?
I'm gonna make one up that's a little more close to what's on the test.
Okay.
I think it'll be better for you guys.
Wait, what does N stand for again?
Number of times you compound per year. Like if you compound quarterly, then N would be 4. If you compound monthly, N would be 12. It's the number of times the interest is applied to the account.
Okay.
So let's
For
see here.
N-
Go ahead.
We don't for N, like we don't always have to use it, right? Like if it just like
If
if
it's
it's
compounding continuously, you didn't use the second equation. But if it's compounding in a certain interval, so let's say this: you invest in an account that compounds interest quarterly. The interest rate is 5%. And after 10 years, you have $20,000 in the account. What was your initial Okay, let me resize that. Okay, here we go. So that's something I could ask. So the 10. What does the 10 represent? And first of all, it's a compounding in a regular interval, so we're not gonna use this equation. That's for continuous. Because that's what n is too large that, you know, this entire base becomes e. So we're using this equation. So what's t? Oh, sorry. What does 10 represent? I already told you. It's t,
T.
right? Yeah. Okay. And then what's r?
Right.
But what am I gonna plug in for?
5.
0.05. You use a decimal.
Point 0.
0.05. Very good. Use a decimal, please. And then what's the 20,000?
RP.
Nope.
It's A.
It's a. It's how much money you have after, because you have $20,000 after time has passed. That's what A represents. T is. Now this I don't know. That's what I'm trying to figure out. And then what's n?
4.
Dude.
4.
4. There we go. Perfect. And you just work it out. 20,000 equals P. And I'm gonna let you guys use your graphing calculator for this because it's I'm starting to realize that to plug this into the scientific calculators, you could do it. It's just a little labor. It's just not as intuitive, I suppose. And I don't want you guys missing points because of that. I think that's kind of lame. I think you guys should. It would be easier to use a graphic calculator. Of course, we use better technology if we have it available. And that's 4, and that's 10. Okay, just to make sure you guys are comfortable with plugging this into the graphing calculator. Go ahead and plug it in and tell what you guys get. I mean, work it all out. And then we'll do another one. We'll do another one like this, and I'll let you guys have figure everything else out. Bill, go ahead.
So when you say like quarterly, why is it 4 and not 1 quarter?
How many quarters are in a year?
Okay.
How many quarters in a football game?
4.
How many quarters in basketball?
But how do you know that I don't know.
How many quarters? Why call it a quarter? Because you're separating the 4. That's all.
So it's
You're overthinking it. Just 4. Like in finance, you have the first quarter of the year, the second quarter, third quarter, and the fourth quarter.
Are you only gonna ask us either daily or quarterly, or continuously?
I'm gonna keep it as quarterly or monthly. I'm not, because some people may not know like days in a year. I mean, it's 365 or
Yeah.
weekly 50. Yeah, I'll keep it quarterly or daily. Sorry, quarterly or monthly.
Okay. But we have to know continuously too, right?
Well, continuously just means you just know to use the other equation with E.
And then you use Euler's number or whatever.
Yeah, of course, and you have a calculator to do that. Okay, so I'm going to do it myself and see if we get the same answer. So try punching in, see if you can get the same answer. All right, let me know if you have an answer. Put it in the chat, or you could just blur it out. And that was round to nearest dollar, by the way. Let's go to the nearest dollar.
12,168.
Great, awesome, very good.
And
Perfect.
do you want us to round to like 200s, or do you want us to like not put the decimals?
I'll tell you how to round. I am going to ask for the nearest dollar, and I specify in the test.
Mr. E.
Hmm?
I like rounded one of like the numbers before a little differently, so I got 12,165. So will that like?
Yeah, that would throw out the answer off. You rounded this, you're saying?
I think so. I like before I got 1.644.
Let me show how I would do it in the calculator. Let me stop showing this whiteboard. Let me pull up my graph calculator here. Let's see here. Okay, so let me share my screen here. Okay, so yeah, so you have like 1 plus 0.05 divided by 4, right? And then we raise that to the 40th power, right? And you probably rounded that. Did you round that part a little too soon, Haley?
Yeah, I made the
Yeah.
I did.
I'm gonna do that. I would
1.644.
do this. I do 20,000 divided by, and if you hit the second button and then the negative symbol, Or you could do this. If you just hit the up key and just hit enter, it just grabs it and brings it down for you.
Okay. So
So
I should
help-
just use that one.
Yeah,
'cause-
it's a good habit to be more precise, especially as you guys move on to pre-calculus and calculus. If you do want to take an AP calculus in a couple of years, you're kind of expected to have very accurate answers, and it's just a habit you want to have, just be able to be more precise with your answers. Especially if we're using this calculator. I mean, with the scientific calculator, then you do have to round because it doesn't store stuff. It's such a weak calculator. But yeah. Anyway, Lizzie, go ahead. We have a question.
Oh yeah, I was just wondering, could
Hmm?
you like talk about like in what context you want to use the 1 plus r
Hmm?
versus 1 minus r equations?
Yeah, that's when you're not doing compounding interest. Then you would use those equations. Like if you're talking about just simply growth or decay.
Okay, so like any sort of like growth or decay equation you use like
Yeah.
those ones.
Technically, actually, you could you are using the 1 plus r 1 minus r for this problem here. It's just that the rate gets chopped up 4 ways because you're not using that rate every year, you're using it 4 times a year. So technically you are still using that equation. It's a little more unique because of the percentage being applied not annually but several times a year.
So does that mean
But I give you
Yeah.
the formula anyway, so you don't have to worry about it. But
okay, so you give us the formula. Okay,
of
good.
course, yeah, for the finance, yeah. It really is very similar to that. I mean, if you kind of compare the two, right? You have an initial value, you have a base, you have an exponent. It's really not that much because, like, let's say n is 4, right? Now, like the second equation, maybe you say, let's look at like how the population of like a certain town is increasing every year. Well, then it's like you're dividing by 1, right? If you're doing every year and multiplying by 1. So they're really not that much different. But if you're doing something 4 times a year, yeah, then obviously this interest rate or this percentage gets applied 4 times a year. So that's what you do r over 4. And if say you're doing it for 10 years, that means you're going to be applying this percentage 40 times, right? Because you're doing 4 times a year for 10 years. That's why you do the time times n. So they're not that much different. They're pretty similar. But again, I'll give you the finance formulas. So it's not something that fell out of the sky. It is growth. It's just adjusted for applying this more than once a year. Let's do another one that will involve continuous. Let me put that in formula up. And let me think here. What do I want to do? Actually, let's do another continuous one. I mean, sorry, like the previous example. Let me make something up here. Start with a $2,000 investment. That's your principal. And after 20 years, it grows up to $100,000. If interest was compounded monthly, what was the interest rates? Okay, and here we go. Here's the formula. I'm gonna let you guys work this out. And remember, this is your P. This is your T. That's A right there. Compound monthly. So n is 12. And we don't know r. And I'll be right back. Just gonna get some water. I'm back. I'm gonna work out two. Someone has the answer, they can type in the chat.
I'm a little confused how you get rid of like everything in the parentheses with like
Well, what's your exponent?
240.
Good. Okay. So you should have 100,000 equals 2,000. 1 plus r over 12 raised to 12 times 20 power. So we need to solve for r, right?
Yeah.
So how do we begin getting r by itself?
Do you divide by 2000?
That's a good start. Good. So you should get 50 on the other side. That's good. And you still have all this junk. That's raised to 240. Okay. What do you think the next step should be?
Do you like do it by the reciprocal?
But yeah, you're on the right track. So what do you mean by that?
Do you do like times the right side by 1 over 240?
Yes,
and
you raise it to the 1 over 240 power. Yes, 100% correct. Yep. And we did do that. Like we did do square roots or like cube roots, or like when we had like x raised to the 3/2 power, you guys need to raise both sides to the 2/3. Like you need to do that. So we've done it. We did it on the previous year. So it's nothing new. You have seen that. I'm just kind of give you a variation of this problem. Okay. So Those go away. And you should get 1.016 on the left side, I think. Maybe a bunch of decimals. And then you're almost home free.
Wait, how do you put that in the calculator? Is that
Um,
just
So you raise it. Great question. There's an exponent button, which is right above the division symbol. It looks like this. So you do 50, and then you just type that in and just do parentheses 1 over 240. I'll do in the calculator with you guys after after we get the answer. I'll show you how to do in the calculator. Someone get an answer for R?
Yeah, it should be 0.197 or
Good.
0.19.
Yep, and so it's 19.7%, which is phenomenal growth. Some of the best tech stocks usually do that well. Like if you invested in Apple or Amazon, yeah, they usually, there's a reason why there's a lot of wealth in the Bay Area. Adrian, go ahead.
So are we only like for the word problems on this test, are we only gonna have ones where it's not continuous? Like we're gonna have ones where this is the setup?
There'll be a continuous one. I haven't done a continuous one yet. I just wanted to show you a variation of this type of formula. That's all. But I mean, there will be a problem where you have to do something continuously for sure. But I can't have you solve. I can't have you do this kind of problem with continuous because then the R is in the exponent, and that involves something called a logarithm, which I haven't taught you guys yet. I haven't taught you guys how to solve for an exponent yet. So, but this was fair because that was as part of a base. I think we could do that.
Wait, mystery.
Hmm?
If let's say you get like 19.2%, are you gonna like take points off?
I
Wait,
don't know.
think it's I think it's just because I used 1.016. Should I use the whole decimal?
Yeah, that's what I'm going to try to do in the calculator right now.
Okay. Oh wait, don't you just like put the answer? Like you just like use the whole
Yeah,
answer.
yeah. I'm gonna
Yeah.
do it right now. Just so let me share full screen. Pull this up again. Okay, so yeah, remember we had 100,000 divided by 2,000. And when you raise it, you go the symbol above division, parentheses. Actually, because it's already up there, you don't have to put parentheses. You can just do that. And then I'm gonna subtract the 1 and then multiply that by 12. There we go. Because remember what we had was this. It was 50 equals 1 plus r over 12 raised to the 240. And that's why I raised both sides to the 1 over 240 power. And then after I did that, then I subtracted the 1 and multiplied by 12. So that's how I would do it, just so your answer is more precise. Okay. Let's do one with continuous. And then we'll do another one with the growth indicator and wrap up the call for tonight. Let me see here. I'll just put one up and just see how you guys do. So here's the formula. Okay. So basically, you're solving for p. And you go and type in the chat once you have the answer. Around 10 nearest dollar, by the way. Yeah, I get 3630, 3631. Yep, 3631. Perfect. And remember, you want to be a little more precise. 0.04, where that is, right? Just make sure whatever decimal is, you just divide by 1,000 by it. So, okay. Last one we'll do. Let me type it up. Okay, here we go.
Is it like a 2 and 1 kind of
Yep,
thing?
yep.
Okay.
Wait, this is the equation. It's like y equals,
Yep.
and then but like I'm trying to remember what it is. It's y equals, and then it's like oh wait,
1 plus
A.
R or 1 minus R.
and then to the t.
Yep.
Okay.
Which is really, in essence, an exponential function.
Wait, so I'm a little confused, like when you use continuous versus like.
Well, the continuous, you'll be told that you're compounding. First of all, it's with interest, with finance.
Yeah.
This is not finance. There's
Yeah.
not interest. There's nothing with interest going on here.
Okay, so basically, whenever you say like annual or
No, it's when I use the word compounding.
okay, all right.
Would the exponent for the first equation be 19?
Yes.
Okay.
And you start at 10,000 people. And what am I putting as a base?
0.04.
Perfect. So we'll do that first. I'll get to the population in 2019.
Mr. E.
Mhm.
So on the test, do you want us to show like I'm doing a lot of it just on my calculator. So if I show like
Mhm.
that equation and then I just do the answer
Yeah,
after.
totally. That's fine. Yeah.
Okay.
So you should get 21. We'll round to the nearest person.
Oh, because there can't be like point of a person.
That'd be weird, right?
Okay.
And then for 2022, obviously that's the new population. Because you have to, start with the population in 2019, which was that. And then you do 1 minus 0.03. And what would be your exponent here?
3?
Yep, because you did it for 3 years, exactly. Right. And then how many people do you have now?
I got
19,228.
Yep,
Yeah, that's
perfect.
what I got.
There we go.
Yeah, that's what I got.
Yep. So that's how the test is going to look. So Yep.
Okay, that sounds good. Thank you so much.
Yep.
Yeah, thank you.
And I'll share this recording so if you guys want to watch again sometime tomorrow morning or later tonight. But obviously you should go to bed soon. But yeah, I'm going to download this and upload to YouTube and then put in the YouTube playlist for the unit, and of course I'll post it to the bulletin board for Schoology.
Perfect.
Thank you very
so
much.
much.
you.
Have a good
If
night.
you
Have a nice
if you guys have any other questions,